Welcome back, my very young apprentices. Today we're going to be doing section 1-4, chapter 1, part 4, the distributive property. What does the distributive property say? Well, for any real numbers A and B, it says this. It says A, if I have a number A, times the sum of two numbers, I can distribute that A over that sum. So in other words, I'm going to take this A and multiply it by the B, and then take the A and multiply it by the C, leaving A times B plus A times C. Okay, we can also do this over subtraction. Let's see, we can take a number A, multiply it by the difference of two numbers, and we can simply take that A and multiply it by the B to get A times B, minus distribute the A over the C and get AC. Now let's see if that works with some real numbers here. Example 4 times the sum of 5 and 3. Now by order of operations it'd be a lot quicker just to take the 5 times the 3 here and get 8. And then we would have 8 times this 4 and get 32. That would be the fastest way and probably the smartest way to do it, but right now we're checking the distributive property. So if I take that 4 times the 5 plus the 4 times the 3, I should get 20 plus 12, and we know that's 32. Now, does it work over subtraction? Let's check it out. Let's take 2 times 12 minus 3. Well, that's just going to be 2 times 9 is 18. We know that. That doesn't work. Let's find out. If I distribute the 2 over the 12, then over the 3, I should get 2 times 12 minus 2 times 3, which is 24 minus 6, which is in fact 18. Okay, now that's probably the long way to do it. We would certainly use the order of operations normally, but what good does this do? Let's find out. Okay, what good does this do? You ever see those kids that can multiply a 2-digit number times a 1-digit number really fast? Well, they're using a trick. It's called distributive property. And the more you practice this trick, the faster you can become at it. We were taught how to multiply these numbers very differently, but here's another way we can multiply them using the distributive property. Well, 7 times 49, I'd probably have to write that 7 below and do it the normal way. But we can also take 7 times 50 and get 350. That's pretty easy to do in our head. So, but what is 49? What is 49? Isn't 49 just 50 minus 1? And if I use the distributive property, I can do that 7 times my 50 really fast in my head and get 350. Minus, and I can take 7 times 1 in my head pretty quick, get 7. Well, I can do 350 minus 7 in my head. That's just 343. So they practice this trick and they get really good at it. Okay, what's 93 really close to? 93 is really close to 90, right? 5 times 90 is 450. I can do that real quick. So what I'm thinking in my head is this. Well, 93 is really close to 90, and in fact, it's just 90 plus another 3, right? Isn't that 93? Well, if I distribute the 5 on that, I get 450, which I said earlier, plus 5 times 3, which is 15. That's easily done in my head. That's 465. Okay. And it even works for mixed numbers. We used to have to change that 8 1/3 to 25 thirds and then multiply, see if we can cross reduce and all that stuff. But isn't this problem, 6 times 8 1/3, just 6 times the sum of 8 and 1/3? Okay, well, I know 6 times 8 is what? 48. And 1/3 of 6? You can do that in your head? Yes, you can. That's just 2. I mean, we were taught what we can cross reduce. That's a 1 and that's a 2. Okay, so it's just 2. And 48 plus 2 is 50. A lot easier, I think. Moving on. Algebraic expressions. Here we're just going to use the distributive property to simplify these expressions. Sometimes they might trick you by putting the 12 on the right. The distributive property still works. Okay? I just go over here first. 12 times y is 12y. 12 times 3 plus 12 times 3 is 36. That's all we do. We're just simplifying it up, getting rid of the parentheses. I often say we got to kill the parentheses. Can we distribute over 3 terms? Sure. 4 times y squared is just 4y squared. Plus 4 times 8y. That's just 32y. 4 times 2 plus 8. Not too challenging. This negative numbers, those get a little tricky. I don't want you to start changing, change opposite stuff. I just want you to think of it the way I say it. Okay, so take the negative 4 times a positive 8 is negative 32. A negative 4 times a negative 3m. Negative times a negative is a positive, so it's plus 12m. Okay. And I leave part D for you when I check your notes tomorrow. Moving on. Combining like terms. Well, what's a like term? A like term are terms that can only be different in the coefficient. Well, there's another strange word. What's a coefficient? A coefficient is a number in front of the variable. So, if I have the number 5x, the coefficient is 5. Okay? There's my coefficient. That's the only thing that can be different when we combine like terms. When we add, and it's only for addition and subtraction. So if I were to take, well, actually to show you how this works and why we can combine the 7 and 3x into 10x, I'll show you why we can. Well, what I'm going to do is kind of a reverse distributive property. And you might be saying, how in the world, why did he do that? Well, if I think about it, the distributive property, if I were to start here, says I can do this. Okay? It says I can take the x times the 7 and get 7x. You can take the x times the 3 and get 3x. So it's a legal move. It's called factoring. We'll learn that later. So, well, I can do what's in the parentheses by order of operations. I can obviously take 7 plus 3 and get 10, right? But in algebra, we like to put the number in front of the variable, and since this is just multiplication, we can rearrange it using the commutative property, 10x. So yes, 7x's plus 3x's is 10x's. I often say 7x raised plus 3x raised is 10x raised. Okay. So, let's use this knowledge in simplifying some expressions. Let's take this first one. Example A. We have 6n minus 4n. I would say something like 6 nickels, take away 4 nickels is 2 nickels. Moving on here. I look at these terms. I have a b squared, I have a 13b, and a 13. Are any of those terms alike? No. The only thing that can be different is the coefficient. Well, the coefficient of the first term is 1, and the second term is 13. That's okay. Those can be different. But what can't be different is this term. The b squared and the b. Those are different too. Well, I can't combine them then. And I can't combine any of them with a constant term either. Therefore, I cannot combine or simplify this expression anymore. So I'm just simply going to write, it's already simplified. Example C. Okay, I'm going to look at that. I got a y cubed. I got a y and a y and a 5. Okay. Well, I can combine the two y terms. I can combine these two. Okay. But I'm going to start with the highest power just because I usually do. Do I have any other y cubed terms? No, so I'm just going to write 4y cubed. Okay. Then I have the power on these y's are 1, so I usually like to go to the variable still. I have 2 yo-yos take away 8 yo-yos, which is really -6 yo-yos, so -6 yo-yos. And then I just have that constant term 5. I have no other constant term, so I'm just going to write +5. Example D. I have 5 terms. Oh, wow. Well, I'm going to start here. I have -6a squared. That is a -6a squared. If you remember, you can do keep, change, opposite if you wanted. So what I'm going to do is I'm going to start with that one. I have no other a squared terms, so I'm just going to write -6a squared. Then I'm going to go to the next power. Well, I have a's here. I have a -2a and a +7a. Well, that's going to leave me positive, so plus 5a. And I also have some constant terms. I have a +4 and a -13. Well, when I combine those, I should get a -9. So -9. Keep it simple with one sign between terms. And the last one, we're going to combine all our ideas together. First thing we need to do is distribute, simplify it up using the distributive property. So if I distribute that 6 across the x and the y, I get 6x plus 6y plus distribute the 4 across. Well, 4 times 5x is 20x. And 4 times the -y is -4y. Keeping it simple, one sign between terms. Then I need to look, do I have any like terms? Sure I do. I have a 6 x-rays and another 20 x-rays. And it doesn't matter if I start with the y's or the x's, I just usually go alphabetical order. Well, 6 x-rays plus 20 x-rays is 26 x-rays. And 6 yo-yos take away 4 yo-yos gives me a +2 yo-yos. And that completes the lesson.